Okay, so now we're going to talk about scientific measurements. In this section, we'll be discussing basically the different types of measurements and their associated units. Okay, so first thing we're going to talk about are the different types of units. The SI units. SI is basically, I think, a French abbreviation for the term International System of Units. And basically, they're in the SI system, there's a single base unit for each type of measurement, and they're shown here. Now, for our purposes in this course, we'll be concerned with the length, mass, time, temperature, and amount of substance measurement. For those of you moving on to General Chemistry 2, we'll be concerned with this unit for one particular chapter which deals with electrochemistry, and I don't anticipate us using the last one at all, luminous intensity, all right? But these are basically the units according to the SI system. The unit of length, the base unit of length according to the SI system is the meter unit. The SI unit of mass is kilogram. The SI unit of time is second. That of temperature is Kelvin, and the amount of substance is mole. We'll be talking about each of these in this particular course. In this chapter, we'll be talking about meter, kilogram, second, and Kelvin. The mole unit will come later on, I think, in chapter 3 or 4. Okay, so before we get into actual calculations and so on, I need to talk about the SI prefixes. And again, this is something you should have met before. These are prefixes which basically, in combination with the fundamental metric units, can either express larger or smaller quantities. And this is the versatility of the metric system as opposed to the non-metric system where you have pounds and so on, pounds, ounces, feet, and so on, all right? There are many prefixes, of course, as you can see here. The list that you see here is not the comprehensive, not the most comprehensive. A more comprehensive list of the different prefixes are given in the packet that is posted in the learning management system that we're using, all right? So you will have access to that packet in your future tests and exams and so on, all right? So you don't need to memorize these, even though what you'll find is that with increasing usage of these prefixes, you'll find that you get to know them after time. Now, there are some common prefixes such as the kilo, centi, and milli. These are the three most common. So kilo means 10 to the 3, right? Centi means 10 to the minus 2, and milli means 10 to the minus 3, all right? So it's very important that you know how to use these prefixes in combination with the fundamental metric units. Now, the first type of measurement we'll be looking at is length and then area. So the base unit of length, as we said before, is a meter. And just to give you a picture as to what a meter looks like, it is basically a little longer than a yard. And of course, you can have smaller or larger units of the length expressed in the metric system when you use in combination with the prefixes. So kilo, remember, represents 1,000. So 1 kilometer is equal to 1,000 meter. Centimeter is 100th. So therefore, 1 centimeter is 100th of a meter or 0.01 meter. And milli means 1,000th. So 1 millimeter is equal to 1,000th of a meter, and so on and so forth. And again, just to give you a picture as to what these different measurements represent, a contact lens is about 1 centimeter in diameter and about 1 millimeter thick, all right? Now, as far as area is concerned, the unit of area is derived from the unit of length. So whatever the unit of length that is used to determine the area, you have to use that unit of length to derive the unit of area. So for example, if the unit of length is meters, then the derived unit of area is meter squared, right? So basically, to find the derived unit of area, you square the corresponding unit of length, all right? Then we get the volume. Now, volume, by definition, is the amount of space that is occupied by an object, and the derived unit of volume, based on the unit of length, would be the cubic meter if the unit of length is meters, right? But you also have other units that are used. Now, this is not an SI unit, but it's still used. in science, the liter unit, and there's a relationship between the liter unit and the meter cube unit. I think I have it here. 1 liter is equal to 1 decimeters cube, right? Now, this is a cube. Let me just explain what's happening here. We have a large cube which is made up of smaller cubes that are stacked on top of each other and beside each other. The size of each smaller cube, the length of each edge is 1 centimeter. So therefore, the volume of each of the smaller cubes is 1 centimeter cube, right? And if you make up a larger cube where you stack them up as shown here, you have 10 cubes this way, 10 cubes that way, 10 cubes going up, then what you'll end up with is basically 1,000 of those smaller cubes, which means that the final volume of the larger cube that is constructed by stacking up the smaller cubes will be 1,000 centimeters cube, all right? So therefore, 1,000 centimeters cube will be equal to 1 decimeter cube, because deci is equal to 10. So 1,000 centimeter cube will be equal to 1,000 10 cube, basically, and therefore that is equal to 1 decimeters cube. So this is just showing you the relationship between the different units of volume. I want to point out that 1 milliliter is the same thing as 1 centimeter cube. So the centimeter cube and the milliliter unit is basically the same thing. And therefore, as a result, the decimeter cube and the liter unit is also the same as well. And just to give you a picture as to what we're talking about here, in terms of the mill unit, there are about 5 milliliters present in 1 teaspoon. So that gives you an idea as to the size of the milliliter unit. Okay, some other quantities of measurement. You have mass, which is basically the quantity of matter in an object. And let me just take some time here to explain something, because in everyday language, people tend to use mass and weight as if they mean the same thing. Mass is the amount of material that is present in an object, while the weight is the force of gravity on that object. Now, the reason why people tend to confuse these two is because the greater the mass of an object, the heavier it is, right? But you need to remember that they're two different things. They're related, but they're different. And the base unit of mass, according to the SI system, is a kilogram, which already has a prefix, kilo, which means 1,000. So therefore, 1 kilogram is the same thing as 1,000 grams is equal to 1 kilogram. So just to give an idea as to what that represents, a liter bottle of soft drink weighs about 1 kilogram. And then, of course, you have smaller and larger units. A common unit of mass is the milligram unit. Milli means 1,000, so therefore 1,000th of a milligram is equal to 1 gram. And then we have the second unit, which is the SI unit of time, base unit of time. And the smaller units that are more commonly used are the millisecond units, the microsecond units, and nanosecond. Milli is 1,000th, micro is 1 millionth, and nano is 10 to the minor 1 billionth, all right? And you can have larger units of time, but typically, even in the sciences, we tend to stick to the traditional older system or non-metric system for the larger units, hours, days, and years, all right? And then we get to temperature. Now, temperature unit conversion is a bit different from the others. For one, we don't use the prefixes. Let me just explain that there are basically 3 units of temperature. Now, the SI unit of temperature that we use is the Kelvin unit. That's the base unit of temperature. But there are some others. We have the Celsius, also known as the centigrade unit. And the Celsius scale is actually based on the properties of water. What was decided was that the boiling point of water was decided to be 100 degrees Celsius. The freezing point of water is made to be 0 degrees Celsius. And that's basically, those two points, basically data points, are responsible, or is based on those data points, the centigrade or Celsius scale is determined, all right? Then we have the Fahrenheit scale, which is most often used in the United States. For some reason, when it comes to, for example, weather reports and so on. Here in the United States, we still use the Fahrenheit unit. In other countries, they use the Celsius unit. And basically, there is a mathematical relationship between the Celsius unit and the Fahrenheit unit, and that is given by the following equation. The temperature in Fahrenheit is equal to 9 degrees Fahrenheit divided by 5 degrees Celsius times the temperature in Celsius plus 32 degrees Fahrenheit, all right? Or if you want to convert from Fahrenheit to Celsius, then you can use this relationship. So it doesn't matter which one you use. Well, it does matter. It depends on what you're trying to convert from or to, all right? So that gives you the relationship between the units of Fahrenheit and Celsius. As far as the Kelvin units are concerned, the units of, let me do a little thing here. The relationship between the units of Celsius and Kelvin is given by this equation. I'm going to squeeze it up here. So this is the relationship here. The temperature in Kelvin, temperature in Kelvin is equal to 9, I'm sorry, not 9. Let me scratch this out. The temperature in Celsius times, I'm just going to put a combination of units here, which would be Kelvin over degrees Celsius plus 273 Kelvin. All right, so this equation here gives you the relationship between the Celsius unit and the Kelvin unit. So all you have to do is plug your Celsius value here and then add it to 273 and you get your temperature in Kelvin. Now, in actual fact, if you look in most literature, this number here should be 273.15, but for our purposes, we'll just round it off to 273 and work with that. Okay, so let me go back to here, get this out of the pen mode. Okay, so let's look at this example here. It says, at home you like to keep your thermostat at 72 degrees Celsius. While traveling in Canada, you find that the room thermostat is calibrated in degrees Celsius. To what temperature in Celsius would you set the thermostat to get the same temperature you enjoy at home? Now, at home, the temperature that you enjoy is 72 degrees Fahrenheit. So, let me go back to the pen mode here. So, remember now, the formula for converting from Fahrenheit to Celsius is temperature in Celsius is equal to 5 degrees Celsius over 9 degrees Fahrenheit times temperature in Fahrenheit minus 32 degrees Celsius, all right? And all we have to do is put the numbers in. Okay, why is this thing not behaving itself? Okay, so this would be equal to 5 degrees Celsius over 9 degrees Fahrenheit times 72 minus 72 degrees Celsius minus 32 degrees Celsius. And let me do the calculation here on my calculator. So 72 minus 32 times 5 divided by 9. Okay, so the answer I got is 24 degrees, excuse me. (24 degrees Celsius). All right. So that's basically, oh, by the way, I made a mistake here. This should be, I need to correct this here. This should be Fahrenheit here, and this would be Fahrenheit here. Okay, so degrees Fahrenheit will cancel out here and here with here. So therefore, the only unit remaining would be degrees Celsius. So this would be the final answer. Okay, so that's a very simple example of conversion of a Fahrenheit value to Celsius. Okay, we're going to stop here for today. And the next slide will deal with some other important topics, namely precision and accuracy in measurements. Okay, until next time.